Okay, for problem number 1, it says, can you represent either of the functions in the example problem with an equation? Explain. If we look at the first one, if we look at the first function at table number A, you can see that the first part of it, the input or the hours, the x value is going up by 1s, and the outputs are going up by 3. The y values are going up by 3. And so our equation would be y equals 3x. We would multiply. 3 times 1 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. And so for the first one, function A can be represented by y equals 3x. For function B, on table B, the input values, the x values, are going up by 1s, but the y values are going down. The first one goes down by 0.75. The second one goes down by 1.25. Then it stays the same, and then it goes down by 0.25. Since it is not going down at the same rate, you cannot represent table B by an equation. You cannot represent table B by an equation. Number 2, it says, suppose you reverse the inputs and the outputs in table B. Would the relationship be a function? Explain. So if we reverse the relationships and we change it and make the week the output and make the inches the input, it would then not be a function because the input values 2 would be used more than once. So no, it is not a function. Because 2 is used twice. That's only because we switched the inputs and the outputs. Problem number 3. It says the table shows the number of concert tickets sold by 5 students. If we look at the input values, the x values, you'll see that each of them are different. Since each of them are different and none of them are used more than once, it is a function. Problem number 4. It says, on the blank graph to the right, add a title and then label and number the axes, and then plot the ordered pairs on the graph. So, the title is going to be calories per serving, because that's what we're talking about. We're then going to label the axes. The input is the x-axis and the output is the y-axis. So the x-axis is servings and the y-output is calories. Then we can number them. Across the bottom, we're going to number them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And going up, I'm going to count by 21s. So I'm going to go 21, 42, 63, 84, 105, and etc. I can then plot the points. I'm going to plot a point at 121, 242, 363, 484, and 505. Again, yours will probably look a little bit nicer than mine, but it should look similar. For problem number 5, it says explain whether the relationship is a function. If we look at our input values, we do have different inputs each time. None of them are repeated, so it is a function. It is a function. And if so, can you represent the data with an equation? If so, write it. So our equation is going to be y equals some number x. one thing when noticing when writing an equation, you can simply look at how much it changes by. We're changing by 21. It goes 21 to 42. We add 21, you add 21, you add 21. So we're going up by 21 each time. So it's going to be 21x. Y equals 21x. Problem number 6. It says substitute values into the equation y equals x minus 3 to complete the table. Then state whether the equation represents a function. So all we're going to do is take our problems. Negative 2 minus 3. Negative 2 minus 3 is negative 5. Negative 1 minus 3 is negative 4. 0 minus 3 is negative 3. 1 minus 3 is negative 2. And 2 minus 3 is negative 1. If you look at our input values, they are all different. None of them are repeated, and so it is a function. Problem number 7 says complete the table to show a relationship that is a function that you haven't used yet. Be sure that you can represent your function with an equation. So I'm going to make my equation y equals 3x. Y equals 3x. When the number and the variable are next to each other, it means multiply. So I'm going to multiply 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. That is going to be my table. It then says describe the relationship between the input and the output values of your function, then represent your function with an equation. Again, my equation is y equals 3x. It is a function. It is a function. Also, if I went the opposite direction, right, it goes up 1, 2, 3, 4. So if I went backwards, it would be at 0. And if I multiplied 0 times 3, that would get me at 0. So it would be proportional. We could also say that because they're going up the same amount each time, it would be linear. It is a linear function. And that is the last problem you had tonight for homework.